Before I talk about the open-ended lab experiment on impedance measurement, I want to give you some theory, and this part will be common to other group as well. In this lab, you will be doing impedance measurements. In a capacitor, the voltage across the capacitor builds up slowly, so it resists the change in its voltage. So the current starts to flow, but voltage actually has a 90-degree delay. So if you were to write this impedance for a capacitor, then we would write as in polar form some voltage minus 90 degrees, which is showing the lateness of the voltage, and this is the current, which is 0 degrees, and minus 90 is same as minus j, so then this turns out to be a number like negative 6j. So because of the fact that the voltage is delayed, you got impedance some negative complex number like negative 3j, negative 4j, something like that. As far as the inductor goes, it resists the change in its current. So the current arrives the inductor slowly. So between the inductor voltage and current, there is this relation where the current is delayed 90 degrees compared to the voltage. So that minus 90 degree, which is the delay, can be expressed as minus j. So this 1 over minus j is positive j. So it turns out to be a number like 8j or 4j, so something positive. Now if you have an RL circuit, then you have R plus jx. If it's a RC circuit, then it becomes R minus jx. And then you can have this plot for the RC. So this is the impedance plot. So you got the imaginary component, which is in the negative. The amount is given as minus j over omega c. And the resistor component is on the real axis, and the combination actually gives you the total impedance Z of C. And you got this theory that you should look. And as far as the RL circuit, we know that the inductor has the positive complex impedance. So together with the resistance, it gives something like this with a positive angle. So the impedance has a negative angle here. So this also shows the phase difference between voltage and current. So in a series RLC circuit, you have both the capacitor and inductor. The impact of a capacitor may cancel out the impact of an inductor. So if XL equal to XC, you have a purely resistive circuit. So the current would be at the maximum when these two cancel each other. But it might be that the impedance of a capacitor is more, so you might have a negative term, or inductance is more, then you might have a positive term for the complex part. We can get an idea on the circuit current by just looking at the resistor voltage. Since there is no way to observe a current directly in analog discovery, we would be looking at the resistor voltage here, and simply scaling with the waveform by resistor R would give us the current. So you can expect this current to be maximum again when capacitor impedance cancels out the inductor impedance. You also need to observe the phase shift. If circuit is purely resistive, the input voltage and the output voltage would be in phase. Now over here it is showing that the output is delayed version of the input, so it's basically shifted. So it is actually delayed. And here is the theory on how to calculate the phase shift from the waveforms. For your circuit, you may want to calculate the phase shift between the input voltage and the circuit current. So the second waveform might be the resistor voltage, which in turn give you idea on the current waveform. So you might want to just select this resistor voltage as your output, and then what you're doing with the output waveform, you're basically measuring the current waveform. This open-ended design problem has 3 parts, and make sure you have equal distribution among members, and you can maybe have each member handle one of the parts, and then you guys are responsible putting everything together. Now this experiment is very straightforward if you know how to work with impedances. So in this circuit you're given the voltage source. So as you can see, the frequency and the magnitude is shown, and then you're also given the current waveform in amperes. And notice that there is a phase shift, so the current is leading. What you need to do is just get the impedance calculated once you put these voltage and the current in polar form. So once you have this represented in polar form, then you can get the impedance Z. So it would be something like maybe 120, 60 degrees, something like that. So once you have this one represented in polar form and that one represented, you take the division and you get the impedance. So as you know, once you get the impedance in polar form, you can obtain the reactive component and the resistive component, and right there you know the amount of resistor you need, amount of reactance you will need. So you might need maybe a capacitor for the reactive part or an inductor. Now it's gonna be very straightforward values. Then the next thing you would do is you should do a multisim simulation, and then just to verify that you're getting these values. So you can apply the input waveform as shown, and then you should be getting the current waveform as shown. And so you can actually use the resistor and just measure the voltage across it, and then divide by value of R to get the current waveform. Make sure to get a screen capture of the schematics and the input and output waveforms. So you need to show the waveforms and kind of show these two that happening. Make sure to use cursors so we know what how you're calculating the phase shift. And then the next thing would be to construct this on breadboard. And these are gonna be straightforward values. Using your components kit, you should be able to just construct the circuit. And in analog discovery, there is a math channel. So you can basically, with the math channel, convert the resistor voltage into the current waveform. So it explains this on this link. Finally, you should be comparing the hand calculation, simulation, and analog discovery results. In the second part, now we got the current is delayed with respect to input. So again, the reactive part will be on the other side. So you find the required values of components. So it's going to be a resistor and a reactance, which might be a capacitance or a inductance. So you're actually designing for those components based on the information given, Again, once you put these in polar form, you're able to get the impedance in polar form and find the components easily. And then make sure to use the component values in the box. And you also want to measure the resistance of the inductor you're using just to have correct calculation. And then you are going to do multisim simulation. Finally, you will construct the circuit on breadboard and obtain the waveforms. So in all parts of the experiment, make sure to get the screen capture of the multisim schematics, the breadboard picture, all the waveforms of the multisim and analog discovery, and with cursors whenever it's applicable shown. And optionally, you can try to match your hand calculation and simulation results by exactly using the measured values. So this is gonna be just something optional. The last part refers to the part B of the procedure where we wanted to make this phase shift disappear. So we're just gonna have pure resistive circuit. So once you have an RLC circuit reconstructed, your current should be something like 12.5 sine omega t without any of the phase delay. So this is gonna be first calculated again. So you will figure so if you got an RL circuit on this part, then it needs to be a capacitor added. If this is an RC circuit, then an inductance needs to be added. So I just don't want to give hints. So this is gonna be an RLC circuit where the impedance of the inductor will cancel the impedance of the capacitor. So you got basically a circuit that is purely resistive. And once you design the circuit, you're gonna run a multisim and observe the phase shift. It should be 0 or very close. Then you do this on analog discovery and again compare your hand calculation and simulation results to the measurement values. And then also make sure to answer what you have gained from working as a team. So did it help you learn better? And also make sure to answer this conceptual question. If any difficulties, please reach us on the discussion forum and do not hesitate to also contact us. Thank you.